In this video, we're going to look at an example of computing the radius and interval convergence of a power series. So, in this problem, we've got the power series 1 to infinity of negative 1 to the n, x to the n over n squared, and we're being asked to find the radius of convergence and the interval of convergence. So, we can start this off using the ratio test. So remember the ratio test, we'll look at the limit of the absolute value of the ratio of consecutive terms. Simplifying, we'll have n squared on top, because this n squared will flip up to the top, and n plus 1 squared on bottom. Both of those are positive, so we don't have to worry about absolute value bars on that. The absolute values will take care of the negatives, no matter if they're positive or negative 1. The absolute value will always make it positive 1, so those go away. And the ratio for x to the n plus 1 over x to the n is just x. Now, x could be positive or negative, so we really do need absolute value bars around that. So now we're looking at taking the limit as n goes to infinity of n squared over n plus 1 squared times absolute value of x. For a fixed value of x, this is going to go to absolute value of x, because this limit of n squared over n plus 1 squared goes to 1. So, in order for this to converge, according to the ratio test, we need the absolute value of x to be less than 1. And that's exactly the form that we need to be able to read off the radius of convergence. So the radius of convergence in this case is 1. For the interval of convergence, we need to worry about the endpoints. So this series is centered at 0. So the center of the interval of convergence will be 0. Radius is 1, so that means our endpoints here are plus or minus 1. It doesn't matter if we put in a plus 1 or a minus 1. If we take the absolute value of the terms of the series, whether we plug in 1 or negative 1, we're always going to get 1 over n squared. Whether we plug in a positive 1 or whether we plug in a negative 1. We get the same series, sum of 1 over n squared. This is a convergent p series, so it converges at both endpoints. It'll converge when we plug in 1, and we converge when we plug in negative 1. So the interval of convergence in this case is the closed interval from negative 1 to 1.